Okay, let's take a look at finding the confidence interval for the population mean with sigma given by hand. So our formula we're going to be working with is here, lower bound and upper bound. So lower bound is x bar minus this z alpha divided by 2 times sigma divided by square root of n. And the upper bound is x bar plus this z alpha divided by 2 times sigma divided by square root of n. So what we're really looking for on these problems, and my pen here, is we need x bar. We need this z alpha divided by 2. Don't worry about that. That's just notation. You can just think of it as z. We need sigma, and we need n. At that point, we can plug it in, just get our answer. So, if I come back to my problem. Noise levels at various urban hospitals are measured in decibels. The mean of the noise levels in 54 randomly selected quarters, so n is 54. And let's come back here. The mean the noise levels in 54 random selected quarters are 63.1. So our mean is 63.1. And the standard deviation of the population is 5.1. So sigma is 5.1. Now those will always be given to you direct. The last one we have to find, it says the lower limit of the 95% confidence interval. So we want a 95% confidence interval. When we draw a picture, it's bell shape more or less, and then you'll put this line here and this line here. This is your left tail, this is your right tail. When we say 95% confidence interval, that means we're putting 0.95 in the middle. Now notice I put it in decimal form. Now all of this adds up to 100%. So if I were to take 1 or 100% minus 0.95, that's going to give us 0.05. Now we're going to take this 0.05, the 5%, and split it into our tails. And so you can put that in your calculator, put in 0.05 divided by 2, and that gives you 0.025. Okay. Now our z alpha divided by 2 is right here. And we have to add up all the area to the left. So I'm going to add these two together. So 0.025 plus 0.95 gives me 0.975. Okay, so now I'm going to get to my table. So I'll pause the video temporarily. Okay, so we just said that we're looking at 0.975. So we're going to look at 0.975 in the middle of our table. Before we looked at the top and left, but now we're looking in the middle. And 0.975, if I come down here and look, it's exact. Now, if it isn't exact, you look for the one closest. You can see where my mouse is circling. That's the 0.975. So I come over to the left. That gives me my first part of my number, 1.9. If I come up, that gives me my hundredths place, 0.06. So this, the 0.975, is going to be 1.96. Okay, so 1.96. Now I'm going to be using those formulas that I already mentioned to you. Lower bound is x bar minus the z alpha divided by 2 sigma divided by square root of n. X bar is 63.1 minus z, which is 1.96, times sigma, which is 5.1, divided by the square root of n, which is square root of 54. So, I'm going to be typing that in here. You just put this in your calculator. And I get 61.74. Actually, it's 61.73972. I guess actually they probably want to round to one decimal place, but if there's one decimal place, it'd be 61.7. Now for upper bound, we're going to have x bar plus z alpha divided by 2 times sigma divided by square root of n. So I'm going to have 63.1 plus 1.96 times 5.1 divided by the square root of 54. And if I type that in the calculator, all I'll do is change the one sign there. I get 64.46. 64.46. Of course, rounded one decimal place. It originally was 64.46028. Rounded to one decimal place, that'd be 64.5. Now, if you've watched the Excel version of this, you see how I got 61.74 and 64.76 there? 61.74, 64.46. So it gives you the same result. So even if you love doing things by hand, I definitely recommend using this spreadsheet to check your answer, because you should get the same answer in terms of your confidence interval.